Okay, so in this video, we're going to discuss some theorems related to chords and circles. The first theorem states in the same circle or congruent circles, if the chords are equal, then the arcs are equal. So this is pretty evident, I guess, but we can represent what's going on. So we have a circle, right? And we have, let's suppose that we have two chords. So we have this chord, let's call it A, B, and maybe we have this chord, let's call it M, N, right? So what the theorem is stating is that if the chords are equal, so if MN, so segment N, it's congruent with AB, then the arcs are equal. So what they're saying is that this piece here, right, of the arc is going to be exactly the same as this. Okay. So then chord AB is going to be congruent or equal, or the measurement, if you want. Remember that we can rewrite this also like this. The measurement of chord AB is going to be equal to the measurement of chord NN, right? And in here we could also call it the measurement, right? If you want. This is exactly the same. All right, so this is what the theorem is stating. Let's see another theorem. So the next theorem states in the same circle or incongruent circle, if the arcs are equal, then the chords are equal. So basically, we have the converse of the previous theorem, right? So maybe in this case, we have an arc. Okay, my bad. This arc. And maybe we have this other arc. Let's put it here, right? And let's call it A, N, and this one here, let's call it Q and P. And if we know that the measurement of arc QP, it's equal to the measurement of arc AM, then it's pretty obvious that the chords that we can draw here are also equal. So the measurement of QP of the segment is going to be equal to the measurement of AM, right? That's what the theorem is stating. Let's review other theorems. And this one, it says, this one is pretty interesting. It says, if a diameter is perpendicular to a chord, then it bisects the chord and its two arcs. So again, we have a circle, right? And we have a diameter. So let's put that the middle of the circle is there. I don't know if it's precise or not, but let's suppose it's there. Okay, so maybe we have a chord. So we have a chord here. We have a chord here. And this chord is the chord AB. And it's saying that if a diameter is perpendicular to a chord, so let's draw a diameter, right? I'm going to try to make it as perpendicular as possible. So maybe like that. And it says that it's perpendicular to the chord, right? And let's call it MN or PQ. Let's change it PQ. Right? PQ. Then what it's stating is that it bisects the chord and its two arcs. So we know that here we have an arc, right? A minor arc, arc AB. So what the diameter is doing is bisecting the chord. That means AB. So if we establish that this point of intersection here, it's the point X, then we know that AX, or the measurement of AX is going to be equal to XB, right? So the two segments are going to be congruent. Also, we know that the two arcs are going to be congruent. We also know that AQ, chord AQ, is going to be congruent with chord QB, right? And also bisects the other arc, the one in the back, the major arc. Okay, so we also know that AP, the chord AP, is going to be congruent with chord PB. All right, that is what it's stating. So this is basically that this is congruent with this, right? The arcs, it's stating that this little arc here is going to be congruent with this one. And the other one is stating that all this is going to be congruent with all that. Okay, so that's basically it, just for you to have it really clear. All right, so let's see another theorem. It says, in the same circle or incongruent circle, if the chords are equidistant from the center, then their legs are equal. So again, we have a circle, right? We have a circle. We have two chords. Let's do it with two chords. So we have that chord. And let's suppose that we have that chord. This one, right? And it's saying, if the chords are equidistant from the center, so from the center, we're here in the center, right? And they're equidistant from the center. So this is happening, right? They have exactly the same length, right? All right, like that. And let's call this center. Let's call it C, right? And this is A, B, B. Let's call this L, and let's call this Q. Okay. All right. So if the chords are equidistant from the center, then their lengths are equal. So what it's saying is, if this distance here, all right, let's call this X and this Y. If XC is congruent with CY or YC, doesn't matter, then, all right, what we know is that the chords are equal. So KL, chord KL, is equal to chord BA. That is what this theorem is stating. Actually, the converse of this is also true, and you can analyze it on your own. Okay, so these are really special theorems that we're going to use to solve problems related to chords, and also to prove things, statements related to chords. Okay, so that's it for this. In the next video, we're going to discuss problems and proofs.